Defects in solids. Defects in solid can be defined as the deviation in the ideal arrangement of the lattice points of the crystal lattice is called as defects in solids. These defects in solid can be classified into two types, that is, point defect and line defect. The point defect can be classified into three types, that is, stoichiometric defect, non-stoichiometric defect, and the impurity defect. The stoichiometric defect found in the ionic crystal is termed as Schottky defect and Frenkel defect. The non-stoichiometric defect found in metals, that is, metal excess defect and metal deficiency defect. The point defect and the line defects are defined as the deviation in the ideal arrangement of lattice points around the given lattice points is called as point defect. That is, this should be the ideal arrangement of lattice points of that crystal lattice. Here there is an empty space, therefore this defect is called as point defect. Next, line defect. The deviation in the ideal arrangement of entire row of lattice points in the crystal lattice is called as line defect. This point defect is further classified into two types, that is, vacancy defect and interstitial defect. This point defect is also called as stoichiometric defect. Firstly, let us understand what is stoichiometric defect. The defect which does not affect the stoichiometry of the crystal lattice is called as stoichiometric defect. Stoichiometry means it is the ratio between the cations and the anions present in ionic crystal is called as stoichiometry of that ionic crystals. So nextly, the classification of point defect or stoichiometric defect. Point defect is classified into two types, that is, as vacancy defect and interstitial defect. Vacancy defect is due to the missing of lattice points from their lattice site is called as vacancy defect. The defect arises when the lattice points occupies the interstitial space is called as interstitial defect. The vacancy defect and the interstitial defect found in the ionic crystals is called as Schottky defect and Frenkel defect respectively. If the vacancy defect and the interstitial defect both found in the ionic crystal, then the vacancy defect is called as Schottky defect. The interstitial defect found in ionic crystal is called as Frenkel defect. Firstly, let us go through the study of Schottky defect and Frenkel defect in the comparison. Firstly, Schottky defect. The defect arises due to the missing of equal number of cations and anions is called as Schottky defect. So if we consider an ionic crystal, one anion is missing from its lattice point and one cation is missing from its lattice site. This kind of defect is called as Schottky defect. Next, Frenkel defect. Frenkel defect means it is the defect arises when cation occupies the interstitial space. When the cation occupies the interstitial space, then defect caused is called as Frenkel defect. So in this ionic crystal, the cation which has to be in this space has been shifted or has been relocated from this location to this location. Therefore, this is called as Frenkel defect. Then the density of the crystal decreases in the Schottky defect. That is due to missing of equal number of cations and anions. The density decreases. In case of the Frenkel defect, it is remains same. That is due to there is no missing of either cation or anion from their lattice points. So here the density remains same because the cations only displacing but it is not missing. So Schottky defect is found in the ionic crystal which has high coordination number. That means highly ionic compound exhibits the Schottky defect. Here in the Frenkel defect, the compounds having low coordination number or less ionic compound exhibits the Frenkel defect. It is found in the ionic crystal in which the size of cation and the anion is almost similar. Here it is found in the ionic crystal where there is the large difference in the size of cation and the anion. Nextly, we shall move on to the non-stoichiometric defect. In case of non-stoichiometric defect can be defined as the defect arises or the defect which does not affect which affect the stoichiometry of the solid is called as non-stoichiometric defect. Therefore, the examples for the non-stoichiometric defects are the metal excess defect and metal deficiency defect. In case of metal excess and metal deficiency defect, there are more number of cations. Therefore, definitely they affect the stoichiometry of that metal. Firstly, let us take the metal excess defect. The metal excess defect may arise due to two reasons. They are due to anionic vacancy or due to extra metal ion in the interstitial space. Firstly, let us take the metal excess defect due to anionic vacancy. The metal excess defect found when the negative ion is missing from its lattice site and leaving the empty space which is occupied by the electron. So this empty space which is occupied by the electron is called as F centers. So definition for the F center is when the anionic vacancy is occupied by the electron, then that anionic vacancy is called as F center. In this ionic solid, This is the space for anion. This anionic vacancy is occupied by an electron. Therefore, this is called as F center. Why we are calling it as F center? Reason behind this is F stands for color. That means forebencher. F stands for forebencher, which means color. So here, when the F centers are they import color to the crystals. When they import color to the crystal, then it is termed as F center. For an example, in sodium chloride, if there are excess of sodium ion, that gives yellow color. Next, in case of potassium chloride, if there are excess of potassium in potassium chloride, that gives violet color. In lithium chloride, if there are excess of lithium ion, it imparts pink color to the crystal lattice. Nextly, we shall move on to the metal excess defect due to the presence of extra cation in the interstitial space. So the defect arises due to the extra cation in the interstitial space, that is called as metal excess defect due to the extra cation in the interstitial space. So here the electrical neutrality is maintained by the electron which occupies the interstitial space. When a metal ion occupies the interstitial space, the number of electron which is equal to the charge of that metal ion occupies the interstitial space. Thereby, it maintains electrical neutrality. In case of Zn oxide, when Zn oxide is heated, the oxygen evaporates as O2 and Zn2 plus ion, which is in excess, occupies the interstitial space. Nextly, we shall move on to the next concept, that is impurity defect. The defect developed when an foreign ion is introduced into ionic solid, then such a defect is called as impurity defect. For an example, in case of sodium chloride, if it contains very small quantity of strontium chloride, the Sr2 plus ion which are present in strontium chloride replaces 2 moles of sodium. Therefore, the defect caused is due to the introduction of SrCl2. Here, Sr2 plus ions are foreign ions. Next, due to this impurity defect, it creates the cationic vacancy. If it creates the cationic vacancies, the number of electron will be in excess. Due to the increase in the number of electron, that increases the electrical conductivity of the ionic solid. It is not electrical neutrality, it increases the electrical conductivity of the crystal. So, we need to conclude that the impurity defect increases the electrical conductivity of the ionic crystal. F centers imports color to the crystals. Thank you.